day, everyone. I still remain Tutor Prince of Bajo Daniel Nicole, also known as the man for all arithmetical biologist. I want us to tackle this question together. But before we delve into it, I plead with you to click on the plus button, like the video, comment so that we can post more videos like this, and also share this video to others to learn from what we are doing. Now, looking at this question in the first place, you may find it difficult to tackle based on how voluminous the questions appear. But then I say to you that this question is very, very easy to tackle. So let's go into it very quickly. The question says that a particle of mass 10 kilograms is placed on a rough plane inclined at an angle arc sine 3/5. Now, one point you need to take into consideration is this: rough plane incline. That is a rough inclined plane, which shows that there must be friction under consideration here. Now let's draw the diagram to actually see how it's meant to look like. So, solution. The first parameter we are going to include here is the inclined plane, the horizontal ground, the angle which is given to us theta to be equal to arc sine 3/5. So we can calculate that with our calculator by pressing shift sine 3/5. We are going to get 36.86989.765, which can be approximated to theta equals 37 degrees. So that means the angle of inclination is 37 degrees. Now we have a mass of 10 kilograms, which means here the weight of the body will be exerted here. That is 10 times acceleration due to gravity. This G here means acceleration due to gravity, which is G, that is 10 meters per second squared. Alright, having done that, a force 80 newtons acts on the particle in the direction parallel to and up the plane. Up the plane. This is the plane. So we have a force that is acting up the plane, which is what? P, that is 80 newtons. What else do we need to do here? Now we're asked to calculate the coefficient of friction between the plane and the particle when it is just about to move up the plane. Now remember I told you that there are two possible forces that you need to consider initially when considering a inclined plane. That is the pulling force and the force capable of sliding that object down. That is mg sine theta. Since m is 10 kilograms, we can say 10g, where your g is acceleration due to gravity, then sine 37, which is sine theta in this case. Now listen carefully. Another point you need to consider here, in order to place your frictional force, is this point here. When it is just about to move up the plane. When it is just about to move up this plane, there will be an opposing force, which is the frictional force that will be acting in opposite direction to it. That means the position of our frictional force will be here. That is F. Are you following me? And it is from this F we are going to get the coefficient of friction. Now, another thing we need to consider here is the normal reaction. Yes, the normal reaction R. And also the force that is acting opposite the direction of the normal reaction, which is what? Mg cos theta. But then m is 10 kilograms, we have 10g cos theta, which is cos 37 degrees. Now, since we have successfully indicated the parameters needed to solve this problem, let us get into solving this problem by considering the horizontal resultant force and vertical resultant force to solve this problem. First of all, let's consider the vertical resultant of this force. Remember, at equilibrium, the net force equals 0. Now, vertically, the vertical resultant will be considered by considering R and 10 acceleration due to gravity cos 37. Remember, at equilibrium, the net force equals to 0. So we can say R minus 10g cos 37 equals to 0. Remember that g is what? 10 meters per second squared. That's acceleration due to gravity. On that note, we have R minus 10 times 10 cos 37 equals 0. So we can transpose it. Remember that 10 times 10 is 100. So transposing this, we have r to be equals to 100 cos 37, which can be gotten with your calculator. 100 cos 37, and that is 79.86. That is 79.86 newtons. Now, we need to consider the horizontal forces. Now, horizontally, what are we going to get? The horizontal resultant. Remember, at equilibrium, the net force equals to 0. The sum of the net forces equals to 0. So what do we need to do here? We're going to consider this force and this other forces here. Now, since these two are acting in the same direction, we add these two, then we subtract this, since this is acting in opposite direction to it, and that equals to 0. So horizontally, we are going to have F plus 10g. Remember, g is acceleration due to gravity, not grams, not that. So that is sine 37, and that, then you subtract this from it, that's minus 80 newtons equals to 0. Then remember that F, according to Hamilton's law of friction, we know that force of friction equals to mu r. But F equals to mu r, where your mu is the coefficient of friction which we are required to solve. On that note, replace F with this, we are going to have what? Mu r plus 10 times 10 sine 37 minus what? 80 newtons equals to 0. But then remember that from the vertical resultant, we have expressed R to be 79.86. So we can put 79.86 here. Doing so, we are going to have mu times 79.86 newtons. Are you following through? Plus, multiply these expressions here, we have 100 sine 37. So if you do that, we are going to have 60.18. 60.18. Are you following through? Minus 80 equals to 0. What else do we need to do? So since we have a product here, we have a difference here. Let's take the difference, then we transpose to express the mu which we are looking for. Now 60.18 minus 80 newtons in this case will give us we have mu times 79.86 newtons minus, if you subtract 80 from this, you are going to get negative 19.82 newtons, and that equals to 0. Now remember that we are looking for mu, and mu has a coefficient here. On that note, we need to actually transpose anything that is attached to it, and that is transposing this. So we have that to be mu times 79.86 newtons equals to 19.82 newtons. So at this point, we are looking for mu. We divide both sides by the coefficient. Now, dividing both sides by the coefficient, dividing both sides by 79.86 newtons. 79.86 newtons. We are going to have, dividing both sides by 79.86 newtons, we are going to have mu times 79.86 newtons divided by 79.86 newtons equals to 19.82 newtons. 19.82 newtons divided by 79.86 newtons. So this cancels out this. We have your mu, which is the coefficient of friction between the plane and the particle required for us to get to be equals to, if you divide 19.82 by 79.86, we are going to arrive at 0.248, which can be approximately written as 0.25. So in all, we can say that the coefficient of friction between the plane and the particle, when it is just about to move up the plane, is 0.25. Don't forget, I still remain tutor Prince Obadiwo Daniel Nicole, also known as the man for Wole Charity Physical Biology. Don't forget to press the plus button, like the video, share to others to learn from it, and also make comments so that we'll be stimulated to do more videos like this. Thank you very much.